Okay, so we've created an integer variable over here, we've created an integer pointer over here, and we set the address of our variable to be contained by this pointer. Right now, we have two different ways of accessing our variable x. The first way is just by using the variable name by itself, x equals 10 or something. Right now, the variable x will have the number 10. The other way we can access our memory of our integer x is through the pointer that is pointing at that address. If we want to reach the actual variable that the pointer is pointing to, we will need to use what's called the dereferencing operator, which uses the asterisk symbol, followed by our pointer's name, and that will give me not the pointer's address, not the pointer's contents, which is the address of x, but rather it will give me the actual variable x. Just as if I would have typed x just like that, I can type star and then the pointer's name, and that will give me the actual variable that the pointer is pointing to. And then I could do whatever I want with that variable. I could give it 1,000,000, or whatever else you would do with a variable. And like I said, this is just as good as typing the variable's name, because by using the pointer with the dereferencing operator, you will reach the actual variable x, and you can do whatever you want with it. So let's not get confused over here. We have used two different operators in three different ways. The ampersand, when placed right before a variable name, whether it's an actual variable or a pointer, that gives us the address of whatever follows the ampersand symbol. Next, when I type a variable type like integer or char, and I follow that with the asterisk, what I'm doing is I am creating a pointer which will point to whatever this type is. And of course I must follow that by a pointer name. Finally, once you've already given an address of some variable to this pointer, so right now this pointer is already pointing to some location in memory of some existing variable. So if you want to access that variable through the pointer, we use the asterisk symbol again, but this time for different reasons, not for the reason of creating a pointer, but rather for the reasons of dereferencing a pointer to get to the bottom of whatever it's pointing to. So try to memorize this. The ampersand plus the name is an address of whatever. Then if you have a type, whether it's a variable like int or char, or even a custom type that you yourself created like soldier or whatever, plus an asterisk and then a name, that would mean whatever type it is of pointer called whatever. Like this over here is a character type of pointer, which is called PTR. Finally, afterwards, this thing over here, when used appropriately after I assigned an address of some variable to the pointer, then what this will do is to dereference the pointer, which is called whatever it is you placed right after the asterisk. So try not to forget all these details. Now let's try and see how pointers can actually help us control variables amongst different scopes, so we can finally get over this scope limitation. Right here at the top, I just created, I declared two different functions. One called increment, which takes a regular variable of type integer, and the other is called increment p, which doesn't take a variable, but rather a pointer to an integer variable. Now let's check out the definition. Here is our plain increment function, which just takes a regular variable and it increments it by 1. As you for sure understand by now, this function will never really work for us, because anytime we pass in a variable, all we get is a local copy, and our original variable that we passed in from some other function won't really be incremented. However, here is our second function called increment p, which takes a pointer to type integer. Let's give our pointer the name PTR. And what we do over here is we dereference the pointer so that we get to the actual variable that is being pointed to, and we try to increment that variable by 1. I like to put parentheses around this little part over here so that I make sure that first of all the pointer, oops, I forgot to give it the right name, PTR, sorry about that. That's our pointer right over here. So I like to put parentheses so that I make sure that first our pointer gets dereferenced, and then once it has finished being dereferenced and we have the actual variable that is being pointed to, I increment that variable by 1. Now let's go to our main function. Right over here I'm creating a variable of type integer called var, and I'm giving it 0. Next I will print out our variable, whatever number it may be holding, which at this point of course is 0, and going to the next line. Next I'm creating a pointer over here called pointer1, and I'm declaring that this pointer will only point to variables of type integer. Next I will assign the address of our variable to this pointer. So right now this pointer will be pointing to the address of this variable. As a matter of fact, just like with regular variables, we can do these two steps all together in one line. And as we will learn later, this is a lot better way to do it. Next, I'm going to print out the stuff pointer1 is pointing to. And I dereference the pointer to get the actual variable that the pointer is pointing to. As we learned, this is just as good as if I would have typed in this case var, which gives me the variable itself. When I dereference a pointer which points to that very same place, or any pointer, I get the actual variable that is being pointed to. Not the address, not the address of the pointer. I get nothing more than the actual variable which is ultimately pointed to at the memory location. Now I call the function increment, and I pass in our variable. Right now my variable is 0, of course, and I would like to increment it by 1, so I pass it into this function. Of course, I will be disappointed because, due to the rules of scope, my variable will not be incremented by 1. Let's prove it. Over here, I'm going to print out again what is inside that variable. I could do either var, of course, or pointer1 dereferenced, whatever I'd like. Same thing at this point. And we check to see if it has been changed by this function, which of course we know it hasn't. Next, I call the increment p function, into which I have to pass a certain parameter, but it's not a variable, it's a pointer. I have to pass in any pointer I'd like, but it has to be a pointer of type integer, just as we declared in the declaration of the function. So at this point I will pass in pointer1 as is. No stars, no ampersands, just the pointer1 just as it is. Just like when I call this function, I pass in var, and I don't have to type in anything else like a asterisk or anything else. Over here also we just pass in the plain old pointer just as it is. And finally I check again to see if it has incremented ever since we passed it into this function. Okay, time to test it and see. Here we go. First of all we have 0, because over here we printed out the contents of our variable var. Next we see the stuff pointer1 is pointing to, and we see 0. That's what we printed out right over here when we dereference this pointer. Again, when you dereference a pointer, you don't get the pointer's address, you don't get the pointer contents, which means the address that it's pointing to, but rather you get the actual variable, whatever it may be, that the address, the memory location has. And it's working because we see that variable 1 has 0, and whatever pointer 1 is pointing to also has 0. Then we see, has it incremented? 0. When we passed var into a function which pretty much just creates a local copy, then of course it doesn't increment our real variable, and our local variable remains unchanged. Finally we see, again, has it incremented 1, which shows us that we have successfully managed to manipulate our local variable, which is local to our scope over here, inside of a function, a different function of a different scope, thanks to the usage of pointers.